Now, as I told you that a restoring force is basically a force which always pushes or pulls the object performing oscillatory motion towards the mean position. So now let us discuss these three pictures. You can see in these three pictures there is a mass which is attached with a spring. One is a case when our spring is stretched and other is a case when our spring is compressed. Now, there is a position known as O, which is known as a mean position when our mass is at its mean position, and X here is basically known as a displacement, and F is the force, which is 0, basically when our object is at its mean position. And then we have taken just 2 points here, like point A and point B, which tells us like how much is the magnitude of the force and how our spring is stretched or compressed. So let us discuss the part A first. So you can see that initially the mass M is at rest in the mean position O, and the resultant force, or like the simple force on the mass, is 0. Now if you can see the other picture, part B, the mass is pulled through a distance x up to extreme position A. Like now your mass is at position A, and then it is released. So the restoring force exerted by the spring on the mass will pull it towards the mean position. So you can see it is pulling it towards the mean position. That's why the arrow is on in the opposite direction of the displacement x. The magnitude of the restoring force decreases with the distance from the mean position and becomes 0 at the point O. However, the mass gains speed as it moves towards the mean position, and its speed becomes maximum at the point O. So due to the inertia, the mass does not stop at the mean position but continues its motion. It doesn't mean like if the force is coming towards the mean position, the mass is coming towards the mean position, then it just stops right there. It does not stop there, but it continues its motion and reaches the extreme position B. Okay, so as the mass moves from the mean position O to the extreme position B, the restoring force acting in towards the mean position steadily increases in strength. Hence the speed of the mass decreases as it moves towards the extreme position B. So what happens? The mass finally comes briefly to the rest at extreme position B. So ultimately the mass returns to the mean position due to the restoring force. So earlier it was like when you just leave your mass there, so it tends to come towards the mean position with the higher velocity, and after some point it comes to its other position, position B. So one more thing, there is a time period of a motion of a mass which is attached to a spring. So like the earlier process that we have discussed, it is repeated and the mass continues to oscillate back and forth about its mean position. So such motion, which is like back and forth motion around a specific mean point, is known as a simple harmonic motion. So one important thing about a simple harmonic motion is a time period of a simple harmonic motion of the mass attached to a spring. So there is a specific formula for that. So that time period is basically equals to 2 pi and then the square root of m over k, where m is the mass which is attached to a spring, k is known as a spring constant, and 2 pi is like the complete period and t is a time period.